3.3 rational equation. Think in your head, what's a rational expression? You should be thinking polynomial over polynomial. Okay, so any equation that has a bunch of polynomials over polynomials all over the place, and there's an equal sign, that's a rational equation. So it's got a polynomial over a polynomial and an equal sign. That's the main thing that you need for these. So here's an example. This is what we're going to do first. So we're going to do this example right here, and you can see this one is a polynomial because it's technically 1 over 1. This one is a polynomial. This is a polynomial. This is a polynomial. That's a polynomial. That is a rational equation because everything is a polynomial or a polynomial divided by another polynomial. So yeah, we're going to do 2 examples, but we'll do this one first. We can do more examples too. Again, it's just the intro, so I was going to start a little slower, but it does not actually matter. Okay, so start a new section in your notes, section 3.3, rational equations. This is where I want you to actually start writing stuff down. Okay, so we have this here. At the very top here, I'm going to write 3.3. So we have section 3.3, and we're going to be solving rational equations. Okay, equations have equal signs. Expressions do not. So the first thing that you should do, in my opinion anyway, is get rid of all the fractions. Okay? We have all these rational expressions here, which are just fractions with x's in them. And you want to get rid of the fractions. Okay? Always the best thing to do first. All right, so the best way to get rid of fractions is to multiply by the denominator. So whatever the denominators are, multiply both sides by those. Okay, it's just a kind of a good rule of thumb for that. A good rule of thumb too is to simplify everything first, like factor it out. So here we're going to have 1 over, I'm going to factor this bottom part out right here that I'm going to highlight. I'm going to factor that out. Okay, so you can factor an x out, then you get x plus 2. Okay, plus x minus 1, that doesn't factor, and x doesn't factor as well. Okay, and we want to get rid of all the fractions. So what we're going to do is we're going to multiply this entire side by all of the denominators. Okay, so this first one right here, I'm going to multiply by x times x plus 2. And I'm going to do the same thing over here, because what you do to one side, you equally have to do to the other. Get something like that. Okay. Now, one thing you don't really need to worry about is, so we multiplied by this denominator here, but what about this one? Well, this one's already there, so you don't actually have to do it twice. Okay. If you wanted to, you can, but as long as every single thing that the denominator is taken into account, which is x and x plus 2, we multiplied both sides by that, you're not going to have any fractions. It doesn't look like that right now, but it will in 1 second once we start doing this problem. But that's the most important thing that you can do on these is get rid of the fractions right away, because once you do that, now it's similar to the stuff we were doing before. Okay, so let's do this here. This one is just times 1. That 1 is meaningless. So you're just going to end up with x squared plus 2x here equals. Now we're going to distribute this yellow right here to this first one here. Okay, so it's going to be 1 over x times x plus 2 times that yellow right there, which is x times x plus 2. Now watch this. This is crazy. Because we multiplied by that denominator, watch what happens to the fraction. Gonski. No more fraction. Great. Okay. Let's keep going. We're going to do the same thing over here. We have x minus 1 over x, and we're going to multiply that by x times x plus 2. Check this out. X over x cancels. Look at that. Okay? If you remember before we were multiplying by rational expressions, you can do that. X over x is 1 over 1. So now we have no more fractions. Look at that. That is insane. So let's simplify everything. I'm going to rewrite this here. Is equal to, well, this is just a 1. So I'm going to put a 1 here. Plus, this is x minus 1 times x plus 2. The ones you don't really need to worry about. So it's really just going to be x minus 1 times x minus 2. Okay, now if you look at this right there, you should notice, wow, that's just a quadratic. We've done those already. We did those in intermediate. We did those in unit 1 of this class. Okay, so the big shift for this unit is is just simplifying that fraction in the very beginning, okay? All those rational expressions that you have here. So all this right here, all we had to do was simplify it first, and then it ends up being similar to the other problems we were already doing, okay? So that should make you feel pretty good. There's only just one extra step basically that you have to do. And by the way, this is a test-like question. So if you're like, well, maybe this one's super easy, he's gonna give us harder ones later. Nope, this is exactly what you're gonna be seeing later, okay? But we are not done, so let's keep going. So we have, let's just simplify this out a little bit here. X squared plus 2x is equal to 1. Over here, you're going to have to grid that out or expand it out however you want. And you would get, let's see here, x squared minus 3x plus 2. That's right. Wait a minute. This is embarrassing. That's supposed to be a plus. Oh my gosh. I copied it wrong. It's supposed to be a plus 2. So that's going to change this. Sorry, everybody. All right, so that's going to be plus x minus 2. There we go. I'm going to zoom in so we can focus on this step right here. All right, what's the first thing I can do here that would make this problem a lot easier? Combine like terms. Now, what is on both sides that I can subtract right away? They're equal on both sides, so I can subtract. Do you notice there's an x squared here and an x squared here? So what you can do is subtract both sides by x squared. So that's gone and that's gone. And now we can combine like terms. Okay. So what I'm going to do next is subtract this x here from both sides. So you're going to be left with x is equal to, so this canceled. X is equal to -1, and that's the answer actually. So that's all you have to do. Okay. That one was nice because the x squared canceled out. They're not always going to do that. Sometimes you have to use quadratic formula, but that one we did not have to use quadratic formula, so it's kind of nice. Remember the principle. If you have fractions, multiply by the denominators, and then you have no more fractions. It makes it a lot easier. Okay. Another thing that you should remember is if you already are multiplying by this denominator here and there's an x in it, then there's no reason to multiply by another x. You can do it though. It's perfectly legal. You're going to get the same answer either way, but it's a lot more work. So why do more work? You don't have to. All right. So for this one, you'll notice that we have a common denominator here and here, which is cool because when we multiply both sides by that, it's going to go away. Before we do anything though, we should probably simplify this as much as possible. So let's factor everything first. So we have 5 over n minus 6 over n squared times n minus 2. So I factored out an n squared from this. Get that. N squared plus 5n minus 6 is going to factor to 6 and n minus 1. Okay. And remember, you have to think of two numbers that multiply here and add to get here. Okay, so it's 6 and -1. So that's review. And then we still have the n squared times n minus 2. Okay. So onward we go. The next thing we're going to have to do is multiply both sides by the denominators. Okay, multiply here. Now, this n is actually already in the n squared here, so I'm not going to do double duty on that. I'm just going to multiply by n squared times n minus 2. That n will automatically cancel out, so there's no, it's not a thing you have to do where you have to multiply it by another n. Again, you can do it, it's kind of a waste of time. It's more work. Okay. So check this out. On the right side, this and this are going to cancel. So no more fraction on the right. That's awesome. Okay. On the left, we're going to have to distribute. So this times this here. Okay. So it's going to be n squared times n minus 2 times 5 over n minus, okay, then we're going to distribute over here. And it's going to be n squared times n minus 2 times 6 over n squared times n minus 2. And that's all equal to n plus 6 over n plus 1, or times n plus 1. Okay. Now, some of you might be thinking, if I'm distributing this orange right here to this red that I just circled, that part that I just circled, can't we just get rid of the denominator right away? Yes, you can get rid of the denominator like that and not even write it down to begin with. That's fine, okay? I'm just showing it for illustrative purposes. So if you notice that the denominators are the same and just wrote 6, that's fine. Otherwise, you can rewrite all this and then you get 6 anyway. Okay? We're going to distribute this to this over here. It's not really distributing, it's just multiplying. But check this out, the n squared over n will cancel. So one of those n's goes away, so you just have regular n. So now you end up with 5n times n minus 2 minus 6 is equal to n plus 6 times n minus 1. Now, we have to simplify everything here, so distribute here, and you're going to end up with a quadratic. Okay, this right here, you're going to have to multiply back, but we already know what the answer is because it's what we started with. So we really just didn't really need to factor it, but you do have to check that sometimes, so it's good to factor it. But I'm just going to rewrite it to where it was before. Okay, we got a quadratic equation, and to use quadratic formula, you have to set it equal to 0. So we're going to minus n squared from both sides. So you're going to get 4n squared over here. I'm going to minus 5n from both sides, so you get 15n over here. You're going to add 6 to both. Oh, that's awesome. Look at that. Add 6, it goes away. Sweet. So that's a way easier quadratic formula to look at. To solve this, you have to factor. So I'm going to factor out an n, and you get 4n minus 15 is equal to 0. Okay, let's solve this out. We have n equals 0, and 4n minus 15 equals 0. So your answer for the other one, if you add 14 to the other side, add 15 to the other side, divide by 4, you should get 15 over 4. So you have two answers here, but I chose this problem to illustrate a point, okay? N is equal to 0, n is equal to 5/4. If you look at the original equation here, can n actually be equal to 0? Can n be equal to 0 here? Are you allowed to divide by 0? No, okay? Dividing by 0 doesn't actually make any sense if you think about it. So you cannot include this. It's called an excluded value. This is considered an excluded value. Long story short, for rational equations, you always have to make sure they're not dividing by 0. This 5/4 is not dividing by 0, so that is the only answer for this one. At 0, it's going to be a asymptote because you're dividing by 0, which means you can't use it because asymptotes don't have values. They go to infinity or negative infinity. Now, this first one that we did, if you notice, x is equal to -1. There is no division by 0 for it, so that's why I didn't actually go over it for that one. But going forward, we're always going to have to check to make sure if there are excluded values, they're not counted. I'm just going to tell you this right now. On your tests, your quizzes, there is always going to be an excluded value. Long story short, excluded values anytime it's a division by 0. For this first one, let's just say the solution was 0. That would cause a division by 0, okay? Or say -2, because -2 would cause a division by 0 as well. It just wasn't the answer, so we didn't have to worry about it.